This is the 2022 AS Paper 1 Pure and Mechanics paper, and that's all. Express this as a single logarithm. You've got the same base and you're taking away log, so you divide the input, so this should be log base 10 of 2 over x. Okay. The graph of the function y equals cosine half x. It's inside, if you imagine brackets here, it's inside of the bracket, so it's affecting the x, and you always do the opposite of what you expect. So instead of squishing it in by a half, you're actually you're actually stretching it out by a factor of 2. So this is the only one that's that, like, you know, brings it out but keeps the y-axis the same. So it's this one here. Find the coefficient of x cubed in the expansion of this. Okay, so you can just use the formula n choose r. This here, where a is the first term and b is the second term, n will always be just the power here, and r is just whatever you want it to be. We want a to have a power of 3, right? But we need to do n minus r. If n is 4, 4 minus r equals 3, so r has to be 1. So you can do 4 choose 1 of this, and then b is obviously just a half the other term. This is 3x to the power of 3, so it's 27x cubed over 2. This is 4 factorial over 1 factorial, 3 factorial. Most of this cancels down, so it's just 4. 4 multiplied by all of that is 54x cubed, so the coefficient is just 54. Find the solutions of the equation this. Okay, so you've got cosine theta and you've got sine theta here. Just write it like this. You know it's going to be a quadratic. We're going to use this identity just so that it's all in terms of one trig function. So you've got cosine squared theta equals 1 minus sine squared theta. Put that into there. Just rearrange a little bit to get that. Make a substitution if you want. You don't have to. Let sine theta equal x. So this is x squared plus 10x minus 3 plus 3. Put it into the formula. You've got a calculator for this paper. You'll get this. Put sine theta back in. This is out of range because sine theta lies between 1 and minus 1. So this is the only solution. If you inverse both sides, you'll get minus 18 degrees. And then you do 180 minus 18 degrees to get the other solution, which is minus 162. Add 360 to both of them to be within range. You'll get this, and that's your answer. You can use synthetic division here. It's best not to, because you can do it in a quicker and more smart way. Here, the only way to get an x cubed is to multiply this by that. So you have ax cubed. You can see very clearly that a has to be 3. Similarly for b, you can either look at for the x, the coefficient of x, or the coefficient of x squared. The only way to get x squared, if we're just picking that one, you have to do either bx squared and then minus 6x squared. That's the only way you can get it. Equals 5x squared. Cancel the x squared, so you'll get that. B equals 11, put that in. The only way to get this constant plus 10 at the end is to do minus 2 multiplied by c. So minus 2c equals 10, that means c has to equal minus 5, and that's it. Find the coordinates of the midpoint. Okay, so you just sum the corresponding coordinates and divide by 2. 7 plus 1 is 8, 8 divided by 2 is 4, 4 minus 2 is 2, 2 divided by 2 is just 1. You have that. Then and then just show that this is the equation of the circle. The equation of the circle is written like this, where AB is the center. Put in 4, put in 1, you'll get this. You need to find R. If this is the midpoint and this full thing is the diameter, the difference between this and this, or this and this, will give you the radius. Okay, so if we just pick these two and you do the differences between them, you'll get this. Square root it, use Pythagoras, you'll get that. R equals root 18, so R squared equals 18. Put that in there, expand, and then just write it like this. It's not too difficult. I'm sure you can do that. You'll get this, and that's the answer. The circle has center C and crosses the x-axis at points D and E. Okay, so we've got center 1, and we've got this equation. At the on the x-axis, y equals 0, obviously. So plug in y equals 0 into there, expand, you'll get this. You can factorize this, just put it into your calculator. You'll get this for one solution, first solution, this for the other. Obviously y equals 0, as we've just said. You've got this. If these are parallel, right, and they're on the same y-axis, sorry, on the same x-axis, I don't know why I said y-axis, on the same x-axis, that means the difference between them is the base of the triangle. Okay, so the difference is 2 root 17, that's the base. The base is 2 root 17, the height is 1, because you're going up from 0 to 1. So you've got half base times height as this, so it's just root 17. And then units squared for the area. A curve has this equation. find the area. Okay, the area enclosed between the curve and the x-axis is 36 units. Okay, you can factorize this to find what the roots are. It's a difference of two squares. You have a roots at a and minus a. Okay, and then I hope you can see that. And then if you integrate this to find the area between the curve and the x-axis, you want to integrate between the limits a and minus a of this function here with respect to x, because it's the x-axis. You've got this. Treat the a squared as a constant term, so this is just a. It'll integrate to a squared x, and then this will be minus a third x cubed. You'll get that. Put in a and then put in minus a and subtract them like this. I've not added a plus c at the end. It doesn't really matter because they'll cancel out anyways. You'll get this. And then just collect it. I'm sure you can do this. This isn't too difficult. You can just simplify it so it looks nice. And then multiply by 3, divide by 4. Or first divide by 4, which is easier, and then multiply by 3, so it's 27. And then just cube root on both sides, so you got a equals 3. A curve has this equation. Show that the x-coordinates of the stationary points of the curve satisfy the equation. This. Okay, let's just write it in a way that's easier to differentiate. This is obviously 9x to the power of minus 1. Okay, if you differentiate that, that's 3x squared minus 6, and then minus 9x to the minus 2. Okay, stationary points occur when dy by dx equals 0, when the gradient is 0. Okay, so set that equal to 0. I'm going to write this like this, and then I'm going to multiply by x squared on both sides, because we've got an x to the 4, and we can make an x to the 4 by doing that, and then divide by 3 on both sides to get what they want. Deduce that the curve has exactly 2 stationary points. Okay, so this is the first derivative that we got. This is actually a hidden quadratic. Let's say let x squared equal y. Plug in y squared and then y there, and then you can factorize this to get this. So y equals minus 1, y equals 3. And then put x squared back in. You can see that this one here, you clearly can't square root a negative number to get real solutions, so this isn't one of the solutions we want. X here equals root 3, but it can also equal negative root 3, so those are the two solutions. Find the coordinates and nature of the two stationary points. Okay, well, this was the equation of the curve, and then this was the first differential, equal to 0 because it's a stationary point, and we've got these two solutions for it. We've already solved that. Just plug them back in. We'll do positive root 3 first to get what the y value is, but you want to plug it into here, sorry, not there. You'll get this, put it into your calculator, you get 0, put in minus root 3, you'll also get 0. Okay, so you've got root 3 0 and then minus root 3 0, and then you want to find the nature of them. So we need to differentiate again, because that tells us the nature of the point. So this is going to be 4x cubed minus 4x. Plug in root 3 and then plug in minus root 3. If you plug in root 3 first, this is clearly positive, greater than 0, therefore it's a local minimum. If you plug in minus root 3, you'll get minus 8 root 3, which is less than 0, therefore this is a local maximum. Write down the equation of the line which is tangent to the curve in 2 places. Okay, well, these are the 2 points, okay? I'm hoping you can see that y equals 0 goes through this one and this one, because they've got the same y value. So, it's just y equals 0. Prove that m squared plus n squared is a multiple of 2, but not a multiple of 4. Okay, m and n both are odd. So if you say let m equal 2a plus 1, and then let n equal 2b plus 1, you can just plug it back into there, and then I'm going to expand to get this. And then here you collect the positive, the plus 2's, you'll get this. You can take out 2 from everything here. So this is, just clearly a multiple of 2. Anything multiplied by 2 is a multiple of 2. So therefore that's always a multiple of 2. Take out a 4, but only from these ones here. Okay, you'll get this. You can see here that this was always 2 more than a multiple of 4. Therefore it never actually is a multiple of 4. Curve C has equation this. Find an equation of the tangent to C at the point 2 and then root 2 over 4. Okay, so if you first of all differentiate this first, we're going to find the gradient first when x equals 2. If you differentiate this to first, what you can say is that this is it's going to be minus 2 root 2 x to the power of minus 3. You could you could do like the the step before it if you really want to, where it equals y equals root 2 x to the minus 2, and then differentiate it. But if you're comfortable just to do this, then go ahead and do it. Plug in x equals 2 into there, you'll get this. Just, expand it, you'll get the gradient is equal to minus root 2 over 4. Okay, so y equals mx plus c, where m equals this. You've got these 2 points, just plug them in. This is kind of GCSE stuff. You'll get this for c, and then just write it back into that form. That's it, that's the answer. I think that's actually not supposed to be there, that's a spoiler. Doesn't matter. Show that the tangent to c at the point 2, and then root 2 over 4 is also a normal to the curve at a different point. Okay, so we've got this equation for, so we've got this equation for this tangent, okay, at that point, and we've got this here equals root 2 over x squared, and then similar here on the same side. Okay, so if we go ahead and set them equal to each other because they're simultaneous equations, multiply by 4 and then multiply by x squared on both sides, and then just rearrange it a little bit to get this, and then just a little bit more to get that. What you can do from now is you can actually factorize this. Just pick a couple solutions. Well, we know that x will equal 2. Oh no, sorry, never mind. We know that x will equal 2. Therefore, x minus 2 has to be a factor. But just try and factorize it any way that you can. You'll get this eventually, okay? And then you can factorize this even more actually to get this. So you've got a solution at 2. You've got a repeated solution at 2, and then you've got x plus 1. Okay, we want the other x coordinates. We don't want this positive 2 because we've already got it. So we need to look at x equals minus 1. So this must equal minus 1. And then the y coordinate is just when we plug in minus 1 into here. Okay, so it's going to be minus root 2. No, sorry, it's going to be positive root 2 because minus 1 squared is just positive. So the y coordinate is just root 2. There. Okay, and then differentiate. We already got this last time, and now plug in x equals minus 1 to get what that gradient is. Actually, no, the gradient's just going to be the same, isn't it? But yeah, you'll get the gradient as 2 root 2. And then what we're going to do is we're just going to show that this is perpendicular to this line here. Okay, so if this is the tangent, and then if this is the tangent at this point, it's perpendicular to the tangent at this point here when x equals minus 1. So this gradient here is this tangent, right? We need to show that this gradient, which is this one here, is perpendicular to this one. We already got what this gradient was. If you remember last time, what was that? I can't even remember. It was minus root 2 over 4. So we need to show that it's a negative reciprocal of each other. Okay, just get the negative reciprocal. So it's going to be positive 4 over root 2. You can do it for either one, you'll get this. Then rationalize this, so this is 4 root 2 over 2. In other words, 2 root 2. Therefore, they are perpendicular. I don't know, I've not rationalized. Oh yeah, I've rationalized it over here, yeah. A car initially at rest. Oh yeah, we're on to the mechanics part of it now. A car initially at rest moves with a constant acceleration along a straight horizontal road. One of the graphs below shows how the car's velocity changes over time, t seconds. Identify the correct graph. Okay, well, it's a constant acceleration. It's a velocity over time graph. Okay, and it's definitely not going to be curved, because if it's curved, the velocity is increasing. Okay, but it's increasing it's not at a constant rate, right? So it's not uniform acceleration. This here, this isn't accelerating, it's staying at the same velocity, which means it has to either be this one, or this one, because if there's a gradient between a velocity and time graph, because velocity over time is just acceleration, that means we must have acceleration. It could be this one here, but the problem with it is that this doesn't begin at rest. All right, it begins up here. Okay, this one does, but it doesn't accelerate uniformly, so that leaves us with just this one. So that's the answer. A horizontal force of 30 newtons causes a crate to travel with an acceleration of 2 meters per second squared in a straight line on a smooth horizontal surface. Find the weight of the crate. Okay, so if it acts down with a force of 30, okay, and we know it weighs, then we know it can weigh like we'll say 15 kilograms. okay, then we know that weight equals mass times gravity. We know what gravity is. So, oh no, we don't even need to because the question gives us it there. Okay, so we can say that weight equals 15g. Okay, and then, but that's obviously in newtons because, you know, weight is just measured in newtons. So it's just 15g newtons. So it's this one here. If you're unsure where I got the 15 here from, it's because if F equals MA and then F is 30 and A is 2, 30 divided by 2 is 15. 2 points A and B lie on a horizontal plane and have coordinates -2, 7 and then 3, 19. Particle moves in a straight line from A to B under the action of a constant resultant force of magnitude 6.5. Okay, that's interesting. So we just want to find the resultant force in vector form. Okay, so we can think about it. Going from A to B, well, how do you get from -2 to 3? Well, that's a jump of 5 in the x direction, and then from 7 to 19 is 12. Right, so we're going 5 right and then 12 up, so you can say that's 5i plus 12j. Okay, we want the magnitude of it, so if you just do Pythagoras on this, it's the square root of the squares, the sum of the squares. That's root 169, which is just 13. Okay, so the magnitude is 13 here, but we don't want 13, we want 6.5. So how can we change it from 13 to 6.5? Well, the way to get from 13 to 6.5 is to multiply by 6.5 over 13. Right, so if we've got this and we multiply it by 6.5 over 13, we'll have the resultant force, which is 2.5i plus 6j. A ball is released from rest from a height of h meters above a horizontal ground and falls freely downwards. When the ball reaches the ground, its speed is v meters per second, where v is less than or equal to 10. Okay, so this is a Suvat equation, Suvat question. The equation that you need to use is v squared minus u squared equals 2as. You can start just writing down values that you know, but before we do that, we can see here, well, we want a v squared and we've got v. If we square both sides, we get v squared is less than or equal to 100, and if we rearrange for v squared here, we can put this inequality in, and then we can say, oh yeah, obviously here I've said that the acceleration is due to gravity, so it's g, and your displacement s is just the height h, so you've got 2gh. You can just put in 100 now because we already know what that is. So you get this. U is 0 because, you know, it starts from rest, so its initial velocity is 0. You'll get this, divide by 2 on both sides to get that, and then just swap it so it looks like this, and that's the right answer. Two particles P and Q are initially at rest at the same point on a horizontal plane. A force of this is applied to P and a force of this is applied to Q. Calculate to the nearest degree the acute angle between the two forces. Okay, so if you just draw this out, okay, you've got this for force P and then this for Q. Okay, well, this angle here, if you think about this, one here, it goes 8 across and it goes 15 up. So the angle is just tan of x is just inverse tan of opposite, which is this 15 here, over 8, the adjacent. Right, so that's 40, that's 815. Inverse tan of that, you'll get 62 degrees. The particles begin to move under the action of their respective forces. P and Q have the same mass. P has an acceleration of magnitude 5 meters per second squared. Find the magnitude of the acceleration of Q. Okay, this is the information from the other page. We know that F equals ma, so we're going to be working with the force, obviously. Okay, so if we have a look at the magnitude of this force, it's just, you know, you can just use Pythagoras on it. It's root 4 squared plus 0 squared, so it's 4 newtons. Okay, and we're saying that 4 equals ma. We know what a is, it's 5. The question tells us it. Okay, so you can find what the mass is, which is 4/5. They've got the same mass, so now we can use F equals ma again with 4/5 on this one. The force of this one is just going to be Pythagoras again, the square root of 8 squared plus 15 squared. That gives us 17. 17 equals ma. Plug m into it, they've got the same mass, and then just rearrange for a to get this. Jermaine and his friend Mina are walking in the same direction along a straight path. Mina is walking at a constant speed of u meters per second. Jermaine is walking 0.2 meters per second more slowly than Mina. When Jermaine is d meters behind Mina, he starts to run with a constant acceleration of 2 meters per second squared for a time of t seconds until he reaches her. Okay, so if hair speed is u, Jermaine's speed is going to be u minus 0.2. Okay, so if we just draw a really simple diagram where we've got Jermaine, we've got Mina, and then we've got the distance in between them. Okay, how can Jermaine catch up to Mina? Well, what he needs to do is he needs to travel the exact same distance as she travels, right? Plus this extra distance d. All right, so Jermaine's displacement has to be d plus Mina's displacement. Okay, where sm is Mina's displacement and sj is Jermaine's. Okay, you've got this CVAT equation. This is the one that we're going to use. The acceleration of Mina is going to be 0 because she's got a constant speed, so you know it doesn't change, so the acceleration is 0. Okay, plug in a equals 0 into there. Her displacement is ut. Okay, we'll use that later. We'll just leave it for now. We'll do the exact same thing, but now for Jermaine using his speed. Okay, his acceleration is, where is it? It's 2, and then half of 2 is just 1, so this is just t squared. Distribute the t to get that, and then just plug this into there, and then this into there, and then you can make them equal to each other, because if you say that sj equals ut plus d by plugging this into there, and these two are equal, you can now equate these together. So you've got these two, equate them together like that. The ut's cancel, and then yeah, that's it. You can just swap it around to get it like looking like that. When Jermaine's speed is 7.8 meters per second, he reaches Mina. Given that u equals 1.4, find the value of d. Okay, so Jermaine's speed is this. Okay, u equals 1.4, so his speed is actually 1.2 meters per second. We've got this equation here, v equals u plus at. His speed, when his speed is 7.8, okay, that's his final speed, and then his initial speed is 1.2, and it equals plus at. His acceleration is 2, if you remember from the other part, so you can just plug those values in to get 6.6 equals 2t, therefore t equals 3.3. We got an expression for d in terms of t, so you can just plug it into it. Got that on the last part. Put this into a calculator. I went the longer way and just did it like this. It's not too difficult. You get 10.23 meters, obviously. Show that. Okay, first of all, let's actually read the question. We've got a car, we've got a caravan behind it. There's a tow bar here. The velocity is between, at time t seconds is between this, and it's given by this. Okay, show that when t equals 15, the acceleration is 0.8. Acceleration is just the rate of change of velocity. And if you want to calculate the rate of change of anything, dv over dt equals a, right? So it's the rate of change of velocity, so that's this. So if we differentiate this, you'll get this, okay? When t equals 15, just plug in when t equals 15, you'll get 0.8 meters per second squared. So that's the, oh no, sorry, that's not supposed to say squared. Oh no, yes it is. I don't know why I said that, yeah. The car has a mass of 1500 kilograms, the caravan has a mass of 850. Show that when t equals 15, the tension in the tow bar is 800 newtons, okay, and the car experiences a resistance force of 100 newtons. Find the total resistance force experienced by the caravan when t equals 15. Okay, if we use F equals ma on the caravan, okay, because we're looking at the caravan, where m is 850, so just, you know, plug it in. We've got the acceleration is 0.8 that we calculated in the last part, so, you know, just put it into your calculator, you'll get 680 newtons. 680 newtons acting on the right, and then in the tow bar you've got 800 newtons as the tension. So you've got 800 newtons acting that way, and then 800 newtons acting in the other way. Okay, so if we say 800 newtons is the resistance force acting forwards from the tow bar, and we've also got another force here. We've got drag. Okay, we'll call it R. That's just the resistance. Now, it's a bit annoying to like think of maybe what's the next step, but if you think about it, the car, well, this caravan, it wants to output 680 newtons. Okay, so it wants to like output a force of 680 newtons, and it's held back by this drag as the resistance, and then you've also got this other resistance. Okay, so, you know, it's going to change the force such that it's actually going to decrease because it's being held back. Okay, so if we've got these two resistant forces acting against it, it's R minus 800 equals 680. Sorry, 800 minus R equals 680, because the total resistance force backwards is 800 minus R, because this is positive 800, this is minus R, and then this is positive 680. So if you just sum these together, where this is a minus, you'll get R equals 120 newtons. Oh yeah, and also let me just point out, this R is actually different from the R. I don't know why I even put that there. Find the driving force being applied by the car when T equals 15. Okay, back here, what did it say? The car experiences a resistance force of 100 newtons. So there's 100 newtons acting backwards. In the tow bar, remember 800 left and then 800 right. So we can say 800 acting left. The, what was this mass? The car's a mass of 1500 kilograms. Okay, so mass equals 1500. Acceleration is 0.8. These two have the same acceleration, and we'll get to that later. Okay, we can use F equals ma to get this 1200 newtons acting forward. Now, the car wants to push forward 1200 newtons, right? And that's the minimum force that it's going to be pushing forward, right? According to F equals ma. And that's ignoring this and this, right? But it also needs to account for this and this, right? So on top of pushing the 1200 newtons, it needs to push an extra 800 newtons and an extra 100 newtons to account for this and that. Right, I hope that makes sense. Maybe just stop and pause and think about that for a little bit. But it needs to push this force, which is the minimum amount that it's going to do, plus these resistant forces, right? Because if these were acting back as, say, negatives, then the total force being output by the car would decrease. But we're saying that the minimum force output by it is 1200, so it can't decrease lower than that. So you need to sum this, and that to get this, and that's 2100 newtons. There is actually another part to this question, but my internet isn't working right now, so I can't actually screenshot the question. But it asks, write down an assumption you made about the bar, and you have to say that the bar is inextensible, or the bar cannot extend. And hopefully that's everything done correctly. Thanks for watching.